This is section 7.2, solving linear systems by substitution. To solve by substitution, you need to follow these steps. First, you solve one equation for one variable. Second, you substitute the result that you got in step 1 into equation 2 to solve for the other variable. 3, you take the result of step 2 and put it back into the equation in step 1 to solve. I know this sounds ridiculous and awfully confusing, but it's really not. Let's take a look at example 1. We have to solve the system of linear equations. The first equation is y equals 3x plus 2, and the second one is x plus 2y equals 11. So for step 1, you have to solve one of the equations for one variable. In equation 1, you already have one of the equations solved for one variable, because equation 1 tells you that y equals 3x plus 2. So that's already been done for you. In step 2, you have to solve what you just found in step 1 into the second part. So you're going to put x plus 2 times the quantity 3x plus 2 equals 11. That's x plus 6x plus 4 equals 11. Or 7x equals 7, so x equals 1. So now we've solved for x. Now you have to take what you just solved for and put it back in the equation that you did not use in step 2. So go back to the original equation, and we're going to try and solve this. So if x equals 1, then in equation 1, y equals 3 times 1 plus 2. That equals 5. So your solution here is 1, 5, the point of 1, 5. And understand what that means. That means that's where the two equations are intersecting, right? What we were finding in the other section. Well, now we're finding the same thing, but by substitution. This is actually much, much more accurate, and it's faster once you get the hang of the steps. You should always take your answer and check it in both equations to make sure it works. So in this example, we're going to solve for the system of linear equations again. This time, they don't tell you what x or y is right off the bat, so you're going to have to solve for it. In equation 1, we have x minus 2y equals negative 6. And in equation 2, 4x plus 6y equals 4. Since x is by itself in equation 1, there isn't any coefficient there, it would be easy to solve for x there. So that's what I'm going to do in step 1. I'm going to change that equation around so that's x equals 2y minus 6. That result you now have to take and put in the other equation. In this case, that's equation 2. So equation 2 is 4x plus 6y equals 4. Substitute what you have for x into that equation. So now we have 4 times the quantity 2y minus 6 plus 6y equals 4. That's 8y minus 24 plus 6y equals 4, or 14y equals 28, and y equals 2. Once you get y equals 2, you have to substitute that back into the first equation. In this case, it's not always the first equation, but it's the equation that you did not use in step 2. So here, x minus 2 times 2 equals negative 6, or x minus 4 equals negative 6, or x equals negative 2. So your solution here is negative 2, 2, and again, you should take that point and plug it back into both equations to make sure that it works. Remember, when you solve a system of linear equations, you're finding the point where the two lines intersect. You can always graph to check your answer, but solving by graphing is not really suggested. I know you were exposed to that in the first section, but it's really inaccurate and there's a lot of time involved. Your calculator can do this though. If you go into the y equals menu, you can type two equations in and then graph it, and it will show you where they intersect. That would be the easier way to do it if you're going to graph. Let's try another example for solving a system of linear equations. Here we have y equals 2x plus 5, and in equation 2, 3x plus y equals 10. Because the first equation tells you what y equals, I would substitute that into the second equation. And that's what I did here. For the second step, I took 3x plus the quantity of 2x plus 5 equals 10. That means 5x plus 5 equals 10. 5x equals 5, or x equals 1. you take that result and you substitute it back into the equation that you did not use in step 2. So for us, that's y equals 2x plus 5. So here, y equals 2 plus 5, or y equals 7. These systems of linear equations are often used when you're comparing the cost of two alternatives. You want to find out when the cost is equal and when it would benefit you to take one alternative over the other. So to find the answer, you have to solve the system, find where they intersect. So let's take a look at this word problem. We're looking at using either an internet service provider or a web hosting company to host our website, to save our files. Both companies will store and maintain the files that make up the web page, but which one is more cost effective? Well, at first you're told that the cost of the internet service provider is a $10 setup fee and $21.95 per month. So the equation for the cost of the internet service provider would be y equals 10 plus 21.95 times x. The cost of the web hosting company is no flat rate or fee at the beginning, just a monthly rate of $22.45 or $22.45. That means the total cost of using the web hosting company would be y equals 22.45 times x. You would use substitution to solve this. You've got two equations now, and you know what y equals from that second equation, so we can jump right to step 2 and substitute 22.45 into that first equation. So we get 22.45x equals 10 plus 21.95x. Here, 0.5x equals 10, or x equals 20. That means that the total cost would be the same for both companies after 20 months. So if you're going to use the service longer than 20 months, you want to use the web hosting company because your cost will just be the 22.45 times x. Right? The cost is going to be higher if you use the internet service provider after 20 months because you're going to have that $10 fee tacked on every month. So you have to understand how to solve it, then what the answer actually means, and what it means for implications going past the time that you get for the intersection. Now this is solving a mixture problem. Systems of linear equations are often used with mixtures too, but mixtures are one of the most difficult kinds of problems you will ever have to do. Okay, so let me give you the setup for this problem, and then I'll tell you how you should always work on them, and maybe you won't find them so difficult. So here we go. Here's the problem. In extremely cold temperatures, an automobile manufacturer recommends that you use 70% antifreeze and 30% water in the cooling system of your car. But your store doesn't have 70% antifreeze. They have 100% antifreeze, and they have 50% antifreeze. So you want to know how many quarts of pure antifreeze and 50% antifreeze should be combined to make 11 quarts of 70% antifreeze. Okay, now the problems are tricky. You'll always have two equations. The first equation should be for the total volume. So just strictly with volume. So you know right away it's going to be equal to 11 because you need 11 quarts. Okay? The second equation is always the percent times the volume to get the desired result, to get the optimum condition, whether it's 70% antifreeze or 90 octane gas or 20% acid. You're going to see all kinds of things like that. So in this problem, the first equation is going to reflect the total volume. So if we let x be the number of quarts of 100% antifreeze and y the number of quarts of 50% antifreeze, because you're going to mix them together, then x plus y is going to equal 11. That's simple, right? It's just strictly volume. The number of quarts of x plus the number of quarts of y has to equal 11. You can't have more than that or it won't fit in your car. Now for part 2, you have to multiply the volume by the percentage of antifreeze to get the desired result. Now 100% antifreeze would be 1, right? A coefficient of 1. So we're going to take 1 times the volume of 100% antifreeze. That's x. So we take 1x plus 0.5y. That's 50% antifreeze times the volume of 50% antifreeze. And that would equal 0.7 70% antifreeze times 11, the total volume. Do you see how that works? Okay, that's very important that you get that second equation correct. So now you're going to solve equation 1 for x. Since x plus y equals 11, then x equals 11 minus y. We take that result and substitute it into equation 2. So we had 1x plus 0.5y equals 7.7. We substitute 11 minus y for x and get 11 minus y plus 0.5y equals 7.7. So y equals 6.6. Now, if y equals 6.6, then x has to equal 11 minus 6.6 because the total volume is 11, and you just heard that one kind is 6.6. That was the 50% antifreeze, right? Was 6.6. So the x, the 100% antifreeze, must be 4.4. So that means that you need to mix 4.4 quarts of 100% antifreeze with 6.6 quarts of 50% antifreeze to get 11 points of 70% antifreeze. Like I said, you're going to see a lot of problems like that with gasoline and acid. That seems to be the big things with mixtures. So just take your time and do those two steps, one for the volume and one for the percentage times the volume to get your desired percentage times volume at the end, and then you will be okay.